Hi, today we are going to watch this video in order to take your notes for Chapter 20. Chapter 20 is called Hypothesis Testing, and it's another part of statistical inference. So if you're on the Chapter 20 portion of your note packet, let's turn the page. Now, let's fill in this flowchart to start off with, explaining kind of the connections and the differences in statistical inference. So statistical inference is divided up into two main parts. The first part is confidence intervals, which we have been studying already. And the second half of statistical inference is hypothesis testing. So I'll give you a second to write those down. These two areas comprise statistical inference. So you're really going to learn about the second half of statistical inference today. Now, for confidence intervals, right below this in the flowchart, a confidence interval is used to estimate a population parameter using sample data. So we're looking for a population parameter, we take a sample, and then we compute the interval in order to give us an estimate of the population parameter. And we use p-hat when we're trying to find a population proportion, and we use x-bar when we're trying to find a sample mean, or a population mean. We'll be doing the sample mean stuff next trimester. On the other side of the flowchart, we have hypothesis testing. And hypothesis testing is to test a claim about a population parameter using sampled data. So notice we're not trying to estimate the population parameter, but we're trying to either prove or disprove someone's claim about a population parameter. So they're really two different things. Many times they will be used in unison though, because first we'll test a claim about a population parameter, and if we find out that the claim is false, then we'll use a confidence interval to estimate where the actual population parameter is located. So hypothesis testing and confidence intervals go hand in hand. Okay. Another name for hypothesis testing is a significance test. Okay, and it's a formal procedure for comparing observed data with a hypothesis whose truth we want to assess. So, we'll move on to the hypothesis themselves. Now, hypothesis is a statement about a population parameter. There will be two hypotheses that we will need to make. The first is called the null hypothesis, and it's denoted with an H with a sub-zero. This is called the null hypothesis. That null symbol, the zero there, it also stands for initial if you're in science classes. So this is our initial hypothesis. And it's the claim about the population, okay? This could be based on previous information. It could be someone just making a claim without prior knowledge, etc. So this is just the initial claim. Then we write a second hypothesis, which we call the alternate hypothesis. And this is denoted H sub A. And this is what we believe to be happening with the population. And this is the one that we're typically trying to prove. So someone might say something like, the percentage of people that are going to vote for Trump in the next election is 50%. And someone else might say, you know what? I don't think it's going to be that high. I think it's going to be less than 50%. So then we would write null and alternative hypothesis based on that information. So we might say that, hey, someone thinks that 50% will vote for President Trump. And then someone else might say, you know, I think that's going to be less than 50%. So that would be our null and alternate hypothesis. So the null is the initial hypothesis, or the beginning hypothesis, and then the alternate one is what we think might be true about the population, and we're going to try to prove it. Okay? And basically, the process is going to be this. Someone will make a claim, and we'll say, all right, if they're right about their claim, then the population mean will be right there in the middle of the distribution. We're going to take a sample, but we don't know which sample we're going to get. We could get one of these samples that are close to the mean, or we could get one that's pretty far away from the mean. But what we know about the ones that are further and further away from the mean is that these are very less likely to occur. And if our sample falls far enough away from what we think should happen, that would be evidence that maybe the null hypothesis is not true. Whereas if we find a sample mean that's very close to the claim, as you see if I draw that purple one in the middle, that sample would seem to coincide with the null hypothesis, that maybe the null hypothesis might be true. So it depends on where our sample falls. If our sample is unique enough, then that would be evidence that we could disprove the null hypothesis. And we'll do this obviously using a z-score. So we'll use a z-score on the sample proportion. At the end of the process, we're going to be able to make one of two statements. We are either going to say that we reject the null hypothesis, which means that we had evidence that that claim was probably incorrect. Or the second conclusion we can say is that we fail to reject the null. Notice neither of those say that we accept the null hypothesis, because that's really not what's happening here. Someone's going to make a claim, and then we are going to look at the evidence, and our evidence is going to be the sample proportion. And if that sample proportion is really far away from what we think it should have been, then we're going to say, you know what, I reject the null hypothesis, it's probably not true, and we're going to say something like, we have evidence that the real percentage would be, in this case, less than 50%. However, if our evidence or our sample proportion is really close to the claim, or the null, then we don't have evidence to reject it. We haven't proven it, but we can't say it's not true. So that's why we say we fail to reject the null. So your conclusions will always be one of those two statements. We either reject the null or we fail to reject the null. Now, at the bottom, stating hypotheses, there are some rules about how we do this. The null hypothesis will always be that P equals a certain value. It's always equality. There's never a greater than or a less than symbol in the null hypothesis. We always claim that P equals a certain value. Now, the alternate hypothesis could be any one of three options. We could say that we think the real P is less than the null. We could say the real mean is greater than the null. Or we can just say, you know what, I just don't think that the P equals the null. So those are your options. The null is always the same. It has to be equal. The alternate is always less than, it's always greater than, or it's not equal to. Those are your options. And you will know which one of these to use based on the context of the question. They'll say right in there, you know, we think it's less than this, we think it's more than this, or they'll say something like, we think it's different or not equal to. So you'll need to state those hypotheses when we do these problems. So let's write a couple null and alternate hypotheses. So example 1 says, suppose the present success rate in treating a certain type of lung cancer is 75%. A research group hopes to demonstrate that the success rate of a new treatment of this cancer is better. So the null would be that P is equal to 75%. We always, take what they say as being true or being the null. Then the alternate says they think they can do better, which means they would cure more people. So the alternate would be that we think the P is greater than 75%. Example 2. Suppose the defect rate of a computer chip is currently 12%. The company that produces them has developed a new process they think will lower the defect rate. So we first use the null, and we use their old defect rate and say that P is equal to 12%. The company thinks that they can lower the defect rate, which would mean make it smaller. So we're going to test to see if the P is really less than 12%. Example 3, suppose the approval rate of a politician is thought to be 65% nationally. The politician's campaign staff thinks this rating is incorrect. So the null would be that P equals 65%. The alternate would be, since they think it's incorrect, they're not saying they think it's more or less, they just think it's wrong, we would say that P is not equal to 65%. We are going to stop there for now. I have to end this video, but move on to the second video that's listed below this one.